Okay, so again, we will initialize the matrix here. And this resets all of your, anything that you changed in CTI, it'll reset it. But we're not looking at this anymore. So now you will see those two buttons are your optimizer. And again, this kind of looks like on the slide, hopefully. The top box are your measures, and the bottom box are all your tolerances. Notice I can scroll over on the right to get through all the tolerances. Here's the goal value, and again, that was your spec limit. So you can open up your results. And if you look here, lower spec limit, upper spec limit, the difference is 10. And there you can see that reflected in your goal value. And same with, this one is plus or minus 5, a total range of 10. That's where your goal values are coming from. So you can change those two if you want, or you can just accept the default and change your measurements. Again, here we have your max and min tolerances that you're able to change, lock, and cost. This is the same as the other part. And down at the bottom, you will see your optimized cost. So I'm just going to click Minimize Cost. So this is just the model as it is. Currently, using the current values, we're getting a cost of $3,800. If I then use this optimizer and look at all of the optimized tolerances and optimized measures, we can get down to 3,000. And this is before I even optimized it all. This is just the model as is. So yeah, you can see the current tolerances right there. Okay. There we go. Okay, so yeah, here you can see these are each of the tolerances. So this tolerance, you can make it cost more. Maybe instead of casting, you're also going to add a machining process. So you can drop the tolerance limits and add more. And notice now our cost is much has gone to $1,800. And that was the tolerance that CTI told us we should update. So you notice it made a huge change because that was a huge contributing factor. Now if I change this tolerance, you can see here I'm making that one, that 1,800. If I minimize cost, notice it didn't change. And that's because this one wasn't contributing as much. So that's why it's important to run your CTI and analyzers first so you can determine which ones are going to have the most effect. Okay, and all of these again are, you can edit and update based on what you can meet on the manufacturing floor. So if you find more details, find more information, and you realize you can do tighter tolerances, then it's going to cost you more. So if you can loosen them, it'll cost you less, and that's just basically what we do. So I'm going to copy this optimized price. So this is, we know this is the least amount we can spend on this model as it is. So now we're looking at the quality, and now I want to see, basically with that price, what kind of quality can I get? So all the measurements are weighted equally in this measure, and that's shown by the number 1 there. So if I paste in here the price from the last, from the cost optimizer, and maximize my quality, you can see it's using that entire budget for the optimized cost. And you can see these are the same results that I typed in from the last window. They're connected. And notice now that my quality value is a negative 159. Again, this is an arbitrary number. And it's, now we're going to assume we have, it only costs $2,000, but let's assume we have $8,000. Notice that the quality value is dropping, getting closer to 0. And your price went way up from $2,000 to $6,500. So it's not using the full budget because the best quality it can possibly achieve, it only needs to spend $6,500. So this is kind of, you can roughly figure out how to improve each of these. And now we can go in and change all your max and min tolerances to improve the quality, because now you have this budget we know we can meet. So I can paste that over there. And when I maximized, notice it didn't change. It used the full budget and it got the same quality value because I didn't change anything else. If I go in and I can, let's see, can change each of these max and min tolerances, and now we're tightening the tolerance. So let's assume we're now going to machine this tolerance. Now you can see our quality got much greater, which makes sense. We're machining it now. But yet our cost, so there you can see how we optimize. And you can change your quality. You can, now I'm assuming I only have $1,000. Notice how the quality increased a lot, meaning the quality got worse. And that's because I don't have enough money to machine things, so the quality is getting worse. Now I have unlimited money and my quality is great. So it's all just all relative. You can try out different values and get your